Hi guys, this is a problem that the marine engineers have already finished. When we did leave off with the naval arcs and systems people, we were halfway through this one. We did part A, which was to determine the power output, and we still had to get the pressure drop across the turbine. So engineers can skip along and or stay if you like, and this one is just to finish up the problem for everyone else. So, point 1 and point 2 are set out for us on either side of our turbine, which makes sense if we want the pressure drop across the turbine. And I've noted an assumption here, which is fair, that 1 is very, very close to the inlet of the turbine, and 2 is very, very close to the outlet of the turbine. And the reason we do that is if there's really no effective pipe length there, there's really very little in the way of friction and minor losses. So we can say that in that case HL is effectively 0. Okay, so let's look at the rest of our energy equation. We can see that we've got same diameter, so therefore A1 is equal to A2, so we should know that V1 is equal to V2 from our continuity equation. And if we take our datum here, we can say that point 1 and point 2, the Z values are both 0, or we can just observe that they're at the same height and that they cancel. So they're gone. HA is gone, no devices adding energy. HL, we said, because of this assumption, is pretty much 0. So HR stays in for our turbine. So this simplifies nicely then to P1 minus P2 over gamma is equal to HR, or P1 minus P2 is equal to gamma HR. Okay, now HR we actually got from part A, and I'm not going to do the calculation here again, but it should be in your notes. So let's just calculate away. P1 minus P2 is equal to gamma is 62.4 pound per cubic foot. So recall that we said that is the imperial equivalent of 9810, and our HR from part A was 36.56 feet. And note we've got cubic feet and feet, no inches there, so our calculation should go fairly straightforward. And we get 2281 pound per square foot, and that is a legitimate unit of pressure, but not the preferred unit. So we really want to convert that. So we can use, we've got 12 inches squared per 1 square foot, and you can do the conversion yourself, but what we should get is 15.8 pound per square inch. There you have it. We'll move on to the next thing.